Because physics is one of the oldest academic disciplines, there has been many new developments of theories. In recent years, researchers have faced difficulties in applying fundamental theories to the universe, which has led them to call for a change in theoretical physics. These researchers began to argue that if a theory is sufficiently elegant and explanatory, then it does not have to be tested experimentally, which would be breaking the philosophical idea of defining scientific knowledge as empirical. But this, however, is incorrect. A theory must be falsifiable in order for it to be scientific. Many advocates that are calling for a change are some string theorists. Because the string theory is the only theory, so far, that is capable of unifying the four fundamental forces, they believe it contains truth even though it relies on extra dimensions that we can't observe. Some cosmologists too also seek abandonment to experimental verification of hypotheses such as the kaleidoscopic multiverse, the many worlds version of quantum reality in which observations spawn parallel branches of reality, and pre-Big Bang concepts. These unprovable hypotheses are quite different from those that relate directly to the real world and that are testable through observations, such as the standard model of particle physics and the existence of dark matter and dark energy. As mentioned earlier, the string theory is a highly complicated theory that attempts to explain the existence of cosmic things. This theory states that subatomic particles are one-dimensional strings instead of zero-dimensional points that exist within high-dimensional spaces and constantly vibrating. This theory also argues that there are at least 10 other dimensions curled up between the subatomic strings. Because the dimensions are wounded up tightly within the space, they are so small that it is currently impossible to observe the particles. The string theory combines quantum mechanics with Einstein's theory of relativity, and although it may contain several explanations for the existence of cosmic things, this theory is not fully developed. Some parts that the string theory provides may be identified with research, experimentation, and time, but it is highly complicated as the calculations can take a lot of time to complete. However, there are other parts of the string theory that cannot be proven because physicists do not have the required materials to conduct experimentation and won't have the materials for the foreseeable future. With this being said, physicists still believe that this theory is scientific. But why is that? One explanation that has no alternative states that there is only one solution to a problem that's convincing, and that people have tried to find solutions to the problems, but others don't find them convincing, such as the string theory. The second explanation to this is that a theory, such as a string theory, can be verified if it's similar in context to other theories that do have an explanation. Because the string theory can be similar to other theories in the field of physics, this second explanation may be able to work. However, since the string theory is separate from other similar theories, then one can't use this second explanation. The third explanation is simple, as it states that a theory can give you more information than is intended to. For example, a physicist can develop a theory which can lead to a solution to another physics problem. With these explanations, it is basically being said that a theory can be scientific by using more theoretical beliefs than empirical evidence. However, this can bring many consequences to theoretical physics. There has been many different experimentations that have proven great theories wrong. There is no way of knowing if there are alternate theories to the string theory. This is because the alternate solutions are not yet found, or the premise might be wrong. To conclude, theories such as quantum mechanics and relativity turned out well because they made predictions that survived testing. Yet, numerous historical examples point out how in absence of adequate data, elegant and compelling ideas led researchers in the wrong direction, from Ptolemy's geocentric theories of the cosmos to Lord Kelvin's vortex theory of the atom. The consequences of overclaiming the significance of theories are profound. The scientific method is at stake. To state that a theory is so good that its existence supplants the need for data and testing in my opinion, risks misleading students and the public as to how science should be done, and could open the door for pseudoscientists to claim that their ideas meet similar requirements. What about it? Physicists, philosophers, and other scientists should hammer out a new narrative for the scientific method that can deal with the scope of modern physics. In my view, the issue boils down to clarifying one question: what potential observational or experimental evidence is there that would persuade you that the theory is wrong and lead you to abandoning it? If there is none, it is not a scientific theory.